Hello everyone, welcome back. This is Engineer Sam Wasabi. So in this video, we'll be looking at problems associated with APs and GPs. So before we begin, do not forget to like and subscribe to the channel. Alright, so let's begin. So we have this question that says find the 100th and the nth term of a GP. So we basically have a series 7 over 2, 7 over 4, 7 over 8, and 7 over 16, then ellipsis keeps on going just like that. So basically, in order to solve this, what we need to do is not so complicated at all. So what we'll do is this. We first have to determine what the common ratio is. So let's find R. R is found by saying term 2 divided by term 1, which is also equivalent to term 3 divided by term 2. So term 2 is 7 over 4 divided by term 1, which is 7 over 2. Which is equal to term 3, which is having 7 over 8, divided by term 2, which is having 7 over 4. So you have 7 over 4 times 2 over 7, cause division into multiplication, and 7 over 8 times 4 over 7. So you have that cancelling with that, and then 2 there 1, 2 there is 2, so you have half. Then this side, basically you end up having, let's just say 4, let's say 1, and 2, so we have 1 over 2. Therefore, you can say that the common ratio is 1 over 2. So we need to find the 100th term. So we need to use the formula nth is equal to a, open parenthesis, r to the n minus 1. So in this case, where n is equal to 100, so we have 100th term being equal to the first term, which is basically equivalent to 7 over 2. So we have 7 over 2 times r, which is 1 over 2 to the power 100 minus 1. Now, if we compute this on our calculators, we'll get a value of 5.522, if I round it off, times 10 to the minus 30 as our final answer. So this is basically our final answer. Now, to find the nth term, use basically the same formula to the n minus 1. So for the nth, just know that where n is equal to n. So we say n is equal to 7 over 2, sorry. Then we have 1 over 2, let's use 0.5, 0.5 to the n minus 1. It's the same as 1 saying 7 over 2, then 0.5 to the n times 0.5 to the minus 1. So if we follow this out by multiplying 7 over 2 by 0.5 to the minus 1, we get the nth being equivalent to a value where we have 7 over 2 times 0.5 to the n times 1 over 0.5. And the nth will now just be equivalent to 7 times 0.5 to the power of n. Like that. So that is how we go about solving this particular question. In the next question, we've been told that to find the sum of the arithmetic series with the first term 1, common difference 3, and the last term 100. So how do you go about solving this? Now be mindful, you can always pause the video and attempt to do this question on your own. With that said, we can now solve. So we have the following data. We have the first term, which is 1, common difference, which is 3, and the last term is 100. Now, we don't know the value of n. So to find the value of n when not given, you assume that what you're trying to find is n. Then since the last term is 100, so we're going to determine the number of terms that are reaching at 100. So say if 100 is the last term, then what is the value of n? Because we're using the formula nth is equal to a plus n minus 1 d. Now let's say we now know the term that is on the nth, which is 100. Let us determine, so when the first term is 1, let us determine the place value. We can say n minus 1, then d is 3. If we follow it out, we have 100 being equal to 1 plus 3n minus 3. So we have 100 being equal to, if we 4 this part out by simplifying, we get 3n minus 2. So we have 3n being equal to 100 plus 2. So we have 3n being equal to 102 divided by 3 over n being equal to 102 divided by 3, which is 34. Which tells us that 100 is at term 34, which tells us that the value of n is basically 34. So we can say that the sum of the first 34 terms is equal to, now we can use two formulas. We can say n over 2, then 2a plus n minus 1, then d, or sum of the first 34 terms is equivalent to where we say n times a plus l over 2, where l is the last term. So we use this one because it's much easier. So sum of the first 34 terms, n is 34 times a, which is the first term 1, and the last term, which is 100, divided by 2. So the sum of the first 34 terms will basically be, now it's just up to us to 4 this out. So we have 34 times 101 divided by 2, we get 1717. And that's the sum of all the first 34 terms. I hope it's clear. Move on to the next example. So find the 15th term of a geometric progression whose 80th term is 192 and the common ratio is basically 2. Alright, so now how we go about solving this? Let's understand this. So we need to find the 15th term. So we don't know the 15th term, but we know that when finding the 15th term, n will be equal to 15. So if at all we're finding the 15th term, what we'll basically do is first understand how we can go about this. So if I'm using nth is equal to a, the brackets r to the n minus 1. Now be mindful, I'm only using this because in our data we have the common ratio being 2, which means it's a GB and not an AP. So if I'm finding the 15th term, saying the 15th term is equal to the first term, which is not known. So we say a, the common ratio is 2 to the power, now it's 15th term, so we say 15 minus 1. So it's going to be the 15th term being equal to, now if we forward this out, or simplify rather, we'll have 1, 6, 3, 8, 4, a. This will be our first equation. So this is what we have as our first equation. Then if we move on to the next part, we have the 18th term. We're being told that the 18th term is equal to 192, which means that in this question, in this aspect, the value of n was 8. So we're saying that the nth is equal to a, open brackets, r to the n minus 1. So the value of this is given to be 192, being equal to the first term, which we don't know. Common ratio is 2 to the power 8 minus 1. So having 192 being equal to, if we simplify this on our calculators, we'll be getting 128a. So 128a is equal to 192. Divide by 128, divide by 128. You have a being equal to 3 over 2. That's the value of the first term. So to find the 15th term, we have 16384 times a, which is 3 over 2. So we can say that our 15th term is basically 224,576. And that's our 15th term. Now in this aspect, we have been told that the sum of the first 20 terms of an arithmetic series is identical to the sum of the first 22 terms. Now, if the common difference is 2, find the first term. So the sum of s sub 20 is equal to the sum of s sub 22. Let's try and find s sub 20. Now, the sum of the first 20 terms means that if we're saying n over 2, then 2a plus n minus 1 d, we know that the data shows that the difference is 2. So for the sum of the first 20 terms, n should be 20. So sum of the first 20 terms is equal to 20 divided by 2. Then we have 2, of which the first term we don't know, plus 20 minus 1, common difference 2. So sum of the first 20 terms is equal to 10, then 2a plus 19 times 2. So sum of the first 20 terms is equal to 10, then 2a plus 38. So we have sum of the first 20 terms being equal to 20a plus 380. Then let's also find the sum of the first 22 terms like manner. We'll do the same thing that we did for our previous sum. So we're saying the sum of the first 22 terms, we'll say n is 22 divided by 2, then 2a plus 22 minus 1, the common difference is 2. Sum of the first 22 terms will give us 11, then we'll have 2a plus 21 times 2. So our sum of the first 22 terms being equal to, what are we going to have now? We're going to have 11 multiplying 2a plus 42. So our sum of the first 22 terms giving us 22a plus 462. So we now know that the sum of the first 20 terms is identical to the sum of the first 22 terms. So I have 20a plus 380 being equal to 22a plus 462. So we can take the a's on one side, and we'll have 20a minus 22a being equal to 462 minus 380. So we have minus 2a being equal to, if we subtract that, we have 82 divided by minus 2 divided by minus 2. Then the value of a is equal to negative 41. And that's the value of a. Now, the last question says, rewrite 0.333 as a series and find its sum to infinity. So how do you go about doing this? Now, we have 0.3333, which just basically says 0.3 bar because it's recurring, keeps on going forever. So what you need to understand that this can be written as a geometric series where we have 0.3 bar being equal to 3 over the first place, which is 10, then we'll go to 100, then we'll go to 1000, and it just keeps on going just like that in ellipses. So this is how it's going to be written. Now, since it's written as a series, we can now find the sum to infinity. But to find the sum to infinity, be mindful that sum to infinity is equal to a over 1 minus r, where a is equal to the first term, which is 3 over 10. Let us find r. To find r, we say term 2 divided by term 1 being equal to term 3 divided by term 2. Term 2 is 3 over 100 divided by term 1, which is 3 over 10, being equal to term 3, which is 3 over 1000, divided by 3 over 100. So I have 3 over 100 times 10 over 3 being equal to 3 over 100 times 1000, should be 1000 somewhere here if I'm not mistaken. So here, yeah, like that, sorry about that. So this will give us, that will cancel out. So we have 1 over 10, that one, that one. So we also have 1 over 10 this side. This tells us that r is equal to 1 over 10. Now, whenever you're finding the sum to infinity, be mindful that if the absolute value of r is less than 1, then we say that the series converges, else we say it diverges. So the sum to infinity is equal to the first term, which is 3 over 10, then over 1 minus r, which is 1 over 10. If we do our computation, right, we'll have the sum to infinity, if we calculate, to come out as 1 over 3. as our final answers. Or the sum to infinity can just be 0.3333, which is 0.3 bar. Just like that. So this is how you go about solving these questions. If you have queries, you can always reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. Let's try and push for that A+.